Hello and welcome back, and in this session we are going to talk about the AWS Certificate Manager. And here is what we are going to implement inside our AWS Certificate Manager demo. So first, user is going to make a request using the URL. That request is going to land on our AWS Route 53. Route 53 is going to forward that request to our application load balancer, and that load balancer is going to point to our EC2 instance where our application is running. But to secure that URL, we are going to use the AWS Certificate Manager, which is going to issue the certificate to us, and we are going to use those certificate records inside our AWS Route 53. And once we have imported those records inside our Route 53, then we are going to use the same URL, but this time we are going to use the HTTPS. Let's break down this whole implementation into multiple steps. So the first thing, we will start with our AWS account. Second, we are going to set up our VPC within that AWS account. Third, we are going to create a subnet inside that particular VPC. Fourth, we are going to set up our Internetgateway. Fifth, we are going to set up our RouteTable. And sixth, we are going to set up our EC2 instance. After setting the EC2 instance, then we are going to create an application load balancer so that an user can access our application running inside an EC2 instance via the load balancer. And for that, we are going to use the DNS name of our load balancer. So after setting up the load balancer, the next thing which we are going to configure is our Route 53. And once we configure the Route 53, then user can make a request using the URL. So here you can see into the diagram, then we will have a Route 53 on top of our load balancer. And that user can use the URL like http://jhook.org, which is my own domain, can be used to access the particular service which is running onto my EC2 instance. But as you have noticed into the diagram, that URL I am using is HTTP. It is not HTTPS. And to introduce HTTPS into the URL, then we need to use the AWS Certificate Manager. So we are going to use the AWS Certificate Manager to generate those certificates, and we are going to use those certificate records to insert into our AWS Route 53. So once we create those records inside our AWS Route 53 after generating those certificates, then we can use the URL that is HTTPS along with my domain. Well, that was a quick overview like what we are going to implement. So let's start with our demo, and here you can see this is my AWS account and this is my AWS console. So let's take a look onto the diagram once again and see what are the components which we need to create. So as we know, this is our AWS account. The next thing which we need to create is the VPC. So I'm just going to go back to my AWS console. In the search box, type VPC, click on the VPC over here, click on create VPC. And you can just choose VPC only, put the name. So I'm just going to put test VPC, and here we need to mention the IP range of my VPC. So I'm just going to use 12.0.0.0/16. And after that, I'm just going to keep the default tenancy and then click on create VPC. And here you can see our test VPC has been created, which you can verify from your VPC section. And here you can see our test VPC has been created. Let's move ahead. The next thing which we need to create is our subnet. So again, go back to our VPC dashboard over here and click on this VPC dashboard link on the left navigation side. And here you will find the options for a subnet. So click on subnet, and here you will find default subnet, but we are not going to use those one. I'm just going to click on create subnet, select the VPC which we have just created because we are still working inside our VPC. Here you can see this is the VPC and this is our subnet. So again, go back to our AWS dashboard under the subnet section, select the VPC which is our test VPC, and here we need to enter the name. So I'm just going to put the name test public subnet 1A, and here I'm just going to choose 1A over here, or I'm just going to write 1A because I'm just using the Europe Central 1A to identify my subnet. So select this availability zone. Here we need to specify the IP range of my particular subnet. So I'm just going to use 12.0.1.0/24 so that I will have a 256 IP addresses for me. I will add one more subnet over here because I just want maximum availability. So I will choose a different zone to provision this subnet. So I'm just going to copy this name from here, go to subnet 2, and I'm just going to change it to 1B. Then availability zone, I'm also going to change to Europe Central 1B over here. And the IP range, I'm just going to choose 12.0.2.0/24. So here is the difference. Here, this IP range is starting from a 2.0 at the end. You can see 12.0 2.0, and this subnet is 12.0.1.0. So that's the basic difference between the IP ranges of my both the subnets. After that, just click on create subnet over here. And here you can see our both the subnets are ready. After creating the subnet, the next resource which we need to create is our internet gateway. So again, go back to our AWS console and onto the VPC dashboard. And here you will find internet gateway. You can find it from the left navigation menu also. So here you will find the option for an internet gateway. So click on it. And here you will find some default internet gateway which has been created. So I'm just going to click on create internet gateway because I don't want to use the default one. So I will create a new one, and here I will put test IGW, which is the abbreviation for internet gateway I'm using. And after that, just click on create internet gateway. And here you can see our internet gateway has been created. But the thing is, you are working inside the VPC. Here you can see this is the VPC and this is our internet gateway. But this internet gateway needs to be attached with this particular VPC. So for that, what you need to do, here you will find an option for attach VPC on the green bar, or either you can go to actions and click on attach to VPC. And here you will find a VPC which we have just created, which is a test VPC. So select that one and click on attach internet gateway. Alright, so after creating the internet gateway, the next resource which we need to create is our route table. So for that, go back to your again AWS console, click on VPC dashboard over here, and from the left navigation menu you will find a route table. So click on this route table. This is the default one. We are not going to use that one. Click on create route table. I'll just close this message box, and here we need to enter the route table name. So I'm just going to use test RT public because this is going to be my public route table so that I will have access to internet. And here we need to choose VPC since we are working within the VPC, and the name of the VPC is test VPC. So I'm just going to select that one. Again, you can check the diagram. So we are creating this route table, and this route table is again under the VPC, and the VPC name is test VPC, which we have just created. Okay, so here I have selected the test VPC. The rest of the things are I'm just going to keep default. Click on create route table. And here you can see our route table has been created. But the thing is, once you create this particular route table, then this route table needs to be associated with the subnet. So here you will see, here I have created some arrows. So this is a route table which is associated with our public subnet. So for that, we need to attach that subnet to the public route table. So go back to your console, click on subnet association. I am under the test RT public. This is our public route table. So click on subnet association over here, click on edit subnet. And here you will find the subnets which we have just created. Select all of it, click on save association. And now we have associated our subnet with our route table. But again, if you take a look onto the diagram, then we need to attach our internet gateway as well so that this public subnet can access the internet. So for that, again, go back there, go to the routes over here, click on edit routes, and here click on add routes, and here type this address, so which means the internet you can access, or this particular subnet can be accessible from anywhere. So this is the IP address for that, and here you will choose internet gateway, and here you will choose test internet gateway, which we have just created. So select that one and click on save changes. And here you can see our internet gateway has been attached with my route table. So again, take a look onto this diagram. So we are pretty much done with our internet gateway, route table, and public subnet, and we have attached all the three components. Moving ahead, the next resource which we need to create is our EC2 instance. So again, go back to your AWS console over here, go to the home page of AWS console, and here in the search box type EC2, click on this EC2. And here you can see there are no instances running. So I'm just going to click on launch instances over here. And here we need to enter the name of the instance. So I'm just going to put test EC2. And here I need to choose the base operating system. So I'm just going to choose Ubuntu over here. And the machine type, I'm just going to use t2.micro. Key pair login, I'm just going to create, or either you can create a new key pair, but I'm just going to stick with the existing one. So this is going to be the key which I will be using. If you don't know, then just click on this create new key pair, and then you will be able to download your private key with your EC2 instance, which is you're associating right now. So that's the key pair thing. Then the important thing is the network setting. So click on this edit over here, and here we need to select the correct VPC which we have just created. So if you take a look onto the diagram once again, so we are working under the VPC, and this is our EC2 instance. So here from the drop down, select the VPC which is our test VPC. Subnet, we have created two subnets. So here you can see both the two subnet, 1A and 1B in the Europe central region. So here I'm just going to choose first subnet. Auto assign public IP, so I'm just going to enable it. So yes, I want to enable the auto public IP for that one. And then we need to create some security groups. So for that, I'm just gonna create keep the default one, which is SSH. The next security group which I'm just gonna put is HTTP, so that I can put HTTP request towards this EC2 instance. And source type I'm just gonna put anywhere, so that anyone from anywhere in the world can access this EC2 instance. So that's why I'm just gonna keep the source type as anywhere. Okay, after creating both the security group, the next thing is the storage. I'm just gonna stick with 8 gigs. That's fine. Go to advanced detail, and here you will find some option like a user data. So here I'm just gonna install some custom packages. So I'm just gonna copy that script from my notepad, and this is script where I'm just gonna install the Apache. So here, this is the script. Here I'm just gonna install and update the package. Then we are gonna install the Apache, and this is the index.html page where I'm just gonna print the host name of my EC2 instance. And once it is done, then it is going to restart the Apache, and this will happen on the boot time when this machine is getting started. So this is the main part of this user data script. All right, so now we are done with this user data script. Then what I'm just gonna do, I'm just gonna click on launch instance. And it will take a couple of minutes to get this instance ready, and I'll be back once this is up and running. After a couple of minutes, my instance is up and running. Let's verify a few details. So here, click on instance ID, and this is the public IP address. So I'm just going to copy this public IP address and paste it over here. And here you can see this is the host home page of my EC2 instance where I have installed the Apache 2. But remember, we are not going to use the IP address, but our aim is to first create a load balancer, then point that domain to this particular IP address that we are going to see later. But just keep in mind, we are just trying to verify our EC2 instance at the moment. Let's move ahead, and the next resource which we need to create is our application load balancer. So let's go back to our AWS console and start setting up our load balancer. So here, this is the home page with the public IP address. I'm just going to close that one, and this is the EC2 instance. So I'm just going to go again to the home page over here, go to EC2. And in the left navigation menu, you will find a section for a load balancing. But before we create a load balancing, we need to create a target group for load balancer. So here in the load balancing section, you will find a target group. So click on this target group, and here we need to create a target group. So target group is just a logical group where we will put our EC2 instances. So for example, we have created one EC2 instance over here. So we can add that EC2 instance into one target group, and one target group can contain multiple EC2 instances, so that our load balancer can point to the target group, and target group can have a bunch of EC2 instances running, so that load balancer can direct the traffic between those EC2 instances. So that's the significance of this particular target group. So let's create this target group first. So here I'm just going to choose instances, and here name. So I'm just going to put test TG for target group. Protocol, I'm just going to keep it HTTP. Then I'm just going to stick with IP4 address, and the VPC, which is important because everything we are doing within this VPC. So this VPC name is test VPC. So I'm just going to select the test VPC. Protocol version HTTP1, that's fine. Health check, I'm just going to keep it default, and then click on next. And here you can see our instance, it is asking, so would you like to include this particular instance into our target group? So just select that one, and here you can click on include as pending below. So include that one over here, and after that create target group. So click on create target group, and here you can see our target group has been created and our instance has been added to this target group. So this register target, as you can see, the count is 1, but if you create a multiple EC2 instance, then you can follow the same procedure to add multiple EC2 instances. So that's all about our target group. Now we will go back again onto our left navigation menu into the load balancing section, and now we will create our load balancer. So here click on the load balancer in the left navigation menu. I will just put it down over here, and here you can see there is no load balancer as of now we have created. So I'm just going to click on create load balancer, and we are going to choose with the application load balancer. So, and here we just need to click on create. Here we need to enter the name of the load balancer. So I'm just going to put test LB. For LB is for load balancer. Scheme is internet facing because I want to be internet this load balancer to be available publicly. IP4, because yes, I am assigning the IP4 addresses, the VPC, which is again important. So again, this load balancer is sitting under the same VPC. So here you can see. So I'm just going to choose the same test VPC over here. And here it will ask for the subnets. So the subnets which we have created. So we have created 1A and 1B subnets. I'm just going to select both the subnet. After that, the security group. So this load balancer, in the load balancer, we also need to enable the same port. So first of all, we need to enable the port 22 for SSH so that we will be able to SSH into our EC2 instance. We need to enable port 80, and also we need to enable the port 443 that we will take a look later. But let's enable the security group for port 80 and 22. So here I'll just click on create security group. And here I'm just gonna name the security group. So I'm just gonna put test security group for LB. Description, so I'll put allow SSH port 22 and port 80. VPC, I'm just gonna select test VPC over here, click on add rule. So I'm just gonna choose HTTP over here, port 80, and I'm just gonna select it from anywhere. Add one more rule. So here I'm just gonna put SSH 22 and anywhere from IPv4, so that anyone from anywhere can SSH or can access the HTTP port. So that's the significance of this rule. And then outbound rule, I just don't want to keep anything. And after that, I'm just going to click on create security group. And here you can see our security group has been created. So I'm just going to copy this name of this security group, go back to my application load balancer, just refresh this list. And here you will find the test security group for LB. Select those security group, go down, and here you can see there are some listeners. So here you can see it is listening on a port 80. So what I'll do, I'll just stick with the port 80. We are just going to see it later when we will be enabling the HTTPS. And after that, you just need to verify a few details over here, and then you just need to click on create load balancer. Here you need to select the target group, which I forgot to mention. So as you remember, in the previous step, we have created a target group where we have already included the EC2 instance. But now our load balancer needs to point to that target group. So here, just from the drop down, select the target group, which is test TG. So that's the target group, which includes our EC2 instance. So just keep in mind. And after that, if you go down and then click on create load balancer. And here you can see our load balancer has been created. So again, go to the load balancer section, and here you can see it is provisioning. So it might take a couple of minutes to get it provisioned. So I'll be back once this load balancer is up and running. Now my load balancer is up and running and the state is changed to active. So click on this load balancer over here and copy the DNS names to verify that our load balancer is pointing to the same EC2 instance or not. So copy this DNS name from here, go to the new tab and hit enter. And here you can see it is pointing to the same EC2 instance which we have accessed using the public IP. So if you take a look onto the diagram once again over here, so here you can see we have completed this setup. So here is the user which is using the DNS name. So this is the DNS name. So this is just an example DNS name I'm taking over here, which is different from the one which I have provisioned right now. So this DNS name has been used for this load balancer, and this load balancer is pointing to our EC2 instance. But still, we don't want to use the load balancer DNS name. We want to use our own domain name. So for that, we need to introduce our Route 53. So here you can see onto this diagram, now we are going to introduce our Route 53, and Route 53 doesn't reside under the VPC. It is a global resource. So whenever you create a Route 53 or hosted zone inside a Route 53, then it doesn't belong to any region or any VPC. So it will be a global resource, just to keep in mind. Alright, so now we are going to create our Route 53, and in the Route 53, once we create, then our user is going to use our URL, and that URL is going to point to the Route 53, and then it will go to the load balancer, and then the load balancer will point to our EC2 instance. And at last, we will have our domain name, which we will be using. But still, we are not using the HTTPS. We will still see HTTP, because first we need to introduce our Route 53 into the system. And once we create a Route 53, then we are going to use the AWS Certificate Manager to set up the SSL. So let's go back to our AWS console and start setting up our Route 53. Here is my AWS dashboard. In the search box, type Route 53. And here we'll find the option. So click on Route 53. And here you will find an option for a hosted zone. So click on this hosted zone over here. And here you will see I have already created the jhook.org, but you don't need to worry. I can show you like how you can set up your own domain inside your hosted zone. So what you need to do, you just need to click on this create hosted zone. So click on this create hosted zone, and here you need to enter the name of your domain. So let's example take test XYZ. This is your supposed to be the domain. I'm assuming that you might be having some kind of a domain which is already reserved for you, or you are the owner, or you have already purchased that domain. So just keep in mind you need to keep the same name. So if let's example say test.xyz your domains, then just put the same name over here into the hosted zone. And here into the description section, you can put any description, but just for this demo purpose, I'm just not gonna keep anything because it's optional. The type, I want to have it as a public hosted zone so that anyone with that particular domain URL will be able to access that particular service. And once you enter this name, then just simply click on create hosted zone over here. And here you can see our hosted zone has been created for test.xyz. If you go back to the hosted zone dashboard, then you will see two hosted zone over here. So let's compare both the hosted zone so that you don't feel that I have not shown you like how to create your hosted zone for jhook.org, which I'm just going to show you later. But let's click on test XYZ, and here you will see two records. One is the name server record, which contains the name server setting, and one is the SOA record, which contains this particular record. So these are the default setting which is been provided by AWS. And if you compare with the other hosted zone, which is jhook.org, which is my own domain. So if you take a look over here, then you will also find the same settings. So there is no difference between those two. So here you will find the name server, and these are the name server setting. And here you will find the SOA, which is this record. So these settings are same. So just create a hosted zone based on the domain which you have purchased. So it might be possible that you have purchased that domain from GoDaddy, Namecheap, or even AWS also helps you to purchase that particular domain. So just keep the same name and create the hosted zone. Now we know like how to create the hosted zone, but I would like to explain one concept, which is our name server setting concept. And this is the slide which I have taken from my previous demo. Because I have purchased my domain from a Google domain, which you can see on the left hand side, and this is my AWS services. So what happens is we have created a hosted zone, and once we create our hosted zone, then we get our name server record, which is from AWS, which you can see over here. But also if you purchase a domain from any registrar, for example, this is my Google domain, but if you purchase from a GoDaddy or a Namecheap or any other service provider, then that particular domain will also have their own name servers. So here you can see these are the records from my Google domain. But things are like we want to point this domain to our AWS services. So what will happen in that case? So we will not be able to use the name server record of our Google domain. So we need to rely on this particular records, which is from AWS. So what we will do, we will just copy these records from our AWS hosted zone for our name server, and then we are gonna paste those records inside my Google domain DNS settings, so that our jhook.org, the domain which I have purchased, will be pointing to the domain name server records of AWS instead of Google one. So once anyone enters that URL, then it will be pointing to the name server records of AWS, and from there we will take that request to our load balancer, and then that load balancer will point to our EC2 instance. So this is how this name server settings work when you purchase a domain from any other service provider. And here I can show you my Google domain name setting. So here, this is the domain which I have purchased, which is jhook.org from Google domain. And here you will find a DNS setting. So click on this DNS setting, and this DNS setting you will find in any service provider, whether it's a GoDaddy, Namecheap, SiteGround, you will find these settings over there. And here I have used the custom name server setting, which is active right now. And if you go down over here, then you will find the option. So here you can see the same settings which I have been updated over here from AWS. So here, if you go over here, then you will see, I'll just verify for you, NS652 AWS DNS. And here you will see NS652 AWS DNS 17.9. And these are the records which are exactly same from AWS. So this is how you point the name server setting if you have purchased any other domain from any other service provider. Let's get back to the topic. So here we have created a hosted zone inside our Route 53, but this hosted zone is still not pointing to our load balancer. So what we need to do, we just need to create a record inside my hosted zone. So again, go back to your AWS console. I'm just going to close this page. And this is the hosted zone of my jhook.org. So here we need to create a record so that it's point to the load balancer. So click on create record. Click on simple routing, click on next. And if you don't know about the Route 53, then just check the previous lab session where I have created the whole Route 53 course and how to create your simple weighted geolocation based routing. So I would prefer to check, I would recommend to check you that particular course if you are not familiar with the Route 53. That is more in-depth session. All right. So here now we are pointing our record, or we are just trying to create a record so that it points to the load balancer. So click on define simple record, select the A record over here, and we are gonna use the main domain, which is jhook.org. So here we need to choose the endpoint. So here, just from the drop down, we are gonna select the application load balancer. So if you take so just select this one first of all. So this is the application load balancer we are pointing. And here you can see this is our Route 53 and it is going to point to this particular load balancer. So here I have selected the type, which is load balancer, and here we need to choose the region where your load balancer resides. So I'm just going to choose Europe Central 1A. And here from that you will find a search box where you can search the load balancer, and this is the load balancer which we have created. So select this load balancer and click on define simple record. And our record has been created. Select this and create records over here. And here you can see now, apart from NS and SOA records, now we have one more record which is pointing to our load balancer, which you can see over here. This is the name of my load balancer. And here you can check the status, and here it shows it's pending. So I'll be back when this status has been changed and it is in sync. And here you can see the status has changed, and now it is in sync right now. All right, so let's go back to our hosted zone once again, and here you can see all the three records. And now I'm just going to open a new tab over here, and I'm just going to type jhook, and I'm just going to type org over here. And it might take a couple of minutes to activate or propagate those DNS settings. So I'll just wait for a couple of minutes to propagate those changes, and I'll be back once those changes has been reflected over here. And after a couple of minutes, my DNS changes has been propagated, and here you can see now I'm able to access the same home page of my EC2 instance using the domain, which is jhook.org. So if you take a look onto the diagram once again, so here we have completed this setup. Now user is able to access the URL without HTTPS. It is still HTTP, and it is pointing to the Route 53, and then Route 53 is going through the load balancer, which is accessing the EC2 instance. Let's move ahead, and the next thing which we need to set up is the HTTPS and SSL, and for that we need to have our AWS Certificate Manager. We are going to use the AWS Certificate Manager to request the certificate, and once we get those certificates, then we are just going to create those records inside our AWS Route 53. And once we import or create those records inside our Route 53, then we will be able to use the HTTPS URL along with our domain. So let's get back to our AWS console and let's start setting up our certificate manager and create our certificates. Here is my AWS console, and to create a certificate, first you need to type the certificate manager over here. So here you will find the option for a certificate manager. So click on this first link over here, and here you will find the option for a request certificate. So click on request a certificate. Since our domain is into our public area so that anyone can access that particular domain, so I'm just gonna use request public certificate. Click on next. Here we need to enter the fully qualified domain, and since we are working with my own domain, which you can find into the Route 53 hosted zone, so I'll just open it once again over here. So click on hosted zone over here and jhook.org. So this is the domain for which I need to create the certificate. So I'm just going to copy this name, go to my certificate manager, and here I'm just going to put the name. So this is my fully qualified domain name for which I need certificates. Second, the validation method, I'm just going to use DNS validation because I have already copied my domain name server record into my Google domain from AWS. So I'm just going to stick with the DNS validation. But in case if you don't know, then you can just use the email validation as well. It will send a validation email onto your registered email ID from where you have purchased the domain, and then you can do the email verification from that side. Key algorithm, I'm just going to stick with RSA 2048. And the tags, I'm just not going to create any tags. Click on request. And here you can see successfully requested certificate with the ID. You just need to refresh this page to view the certificate. So refresh this one, and here you can see our certificates are ready. Now, if you take a look onto the diagram once again, then we have created the certificate over here. But now we need to create this record of this certificate into the Route 53. So again, go back to our AWS console over here. So here you can see this is our certificate. If I'm just going to refresh it once again, so here you can see the status is pending validation. So for that, what we need to do, we just need to click on this certificate, and here you will find this particular record. Like this is the record which we need to create the record inside the Route 53, or in another way I can say we need to push this certificate records into the Route 53. And for that you will find the option create records in Route 53 button over here. So just click on this button over here. And here you will find create record. So this you just need to click on this orange button, and you just need to push this record into the Route 53. So click on create records, and here you can see successfully created the DNS records. And if you go to the Route 53 over here, so I have not refreshed this page over here, and these are the 3 records which we have previously created. So what I need to do, I just need to refresh this one, and you will see a one more record for our certificates. So I'm just going to refresh this one. And here you can see this is the record which has just been generated over here. And if I open this one a little bit more, then if you copy this ID from here, and if you go to the certificate manager, and if you try to find it over here, then here you can see this is the CNAME record which has been just pushed or just has been created to the Route 53. After we created the Route 53 record, we need to refresh this page so that this status pending validation should go away. So I have waited for a couple of minutes, and after that I have just refreshed this page, and here you can see the status is issued. Now the certificates has been issued, and those records has been updated properly into our hosted zone of my domain. Alright, so before we access the URL with HTTPS, we still need to work on the load balancer still. So if you open the load balancer once again, so I'll just open my AWS console, go to home page, and if I go on to the EC2, because load balancer resides into the EC2 dashboard. So in the left navigation menu, click on the load balancer and click on the test LB which we have just created for this whole setup. And here you will find listeners and rules. So the listener rule is only for HTTP. It is not for HTTPS. So we need to add one more listeners over here for HTTPS. So what we need to do, we just need to click on add listeners over here. And here you will find a protocol. So HTTP already exists, so we don't need to change that. We just need to use HTTPS. And as soon as you use the HTTPS, then the port will change to 443, which is the default one for HTTPS. And after that, you need to choose the forward to target group, and the target group is test target group over here, because that's the target group where our EC2 instance is present. Moving ahead, the next thing which we need to set up is our certificate manager. So into the secure listener setting, you will find an option from ACM, which is our AWS Certificate Manager. And here you will find a drop down, and here you will find a certificate which is jhook.org, which we have just requested. So select this certificate, and after that you just need to click on add. So click on add over here. And here you will find the two listener rules. One is for HTTP and another one is for HTTPS. One more thing over here, since we have enabled the HTTPS and port 443, then we need to enable, or we need to open the security group for HTTPS as well. So again, in the same load balancer, which is our test LB, where we have already configured the listeners and rule for HTTP and HTTPS, we need to go to the security. And here you will find the security group. One is the default one, and one is the another one, test SG security group, which we have created. So open the security group. And here we need to add an inbound rule for HTTPS as well. Otherwise your request will not go through. So here you can see, if you click on edit inbound rule, then here you will find the HTTP and SSH, but we have not set the inbound rule for HTTPS. So click on add rule over here, and from the drop down select HTTPS, and here you need to select from anywhere. So anyone from anywhere can access this particular domain, and that domain will let you through the load balancer, and then load balancer will check these security group to let the request go through. So we have enabled the HTTPS for our load balancer as well into our security group, and then click on save rules. And now you can see our inbound rule is allowing HTTP, HTTPS and SSH requests which are landing on this particular load balancer. Alright, so now we are done with our setup, and let's verify by accessing the URL. So I'll close this one, and I'll close this one also, and I'll open a new tab over here. And first of all, let's try to access jhook.org without HTTPS. So this is a simple URL which I'm putting, and here you can see this is the icon which says connection is not secure, which means I'm just trying to access it with HTTP. So this is accessible. I'm just gonna open one more tab, and here I'm just gonna type HTTP. Sorry, I just need to type HTTPS, and here I will type jhook.org. And here you can see now I am able to access, and that particular error message connection is secured now. So now we are having both the URL open, which is like a non-secured one, and this one is secured. So at least the verification part is good. At least we are able to use the HTTPS inside our URL, and our both the URL patterns are working. But the thing which we need to notice over here is we need to stop the HTTP request, or at least we need to redirect this particular request which is coming without HTTPS to our HTTPS part. So the next thing which we are going to fix is to redirect this particular request where we don't put HTTPS, and we should redirect this request to land on this HTTP URL. So how to fix that redirection? So again, you need to go to your AWS homepage over here, go to your EC2 and go to your load balancer. So in the left navigation menu, you will find a load balancer over here. Click on this particular load balancer and go to the listeners and the rules section. And now we are interested into the request only for HTTP. We want to block that request, not block the request, but at least let go that request and redirect it to the HTTPS. So click on this HTTP over here, and here you will find these rules over here. So click on this default rule, and here we need to click on actions, click on edit rules, and here we need to redirect this particular request. So for that, what I'm just gonna do, I'm just not gonna forward this request to the target group, but instead I'm just gonna use the redirect URL. So here I'm just redirecting this URL to the HTTPS, and the port is 443. And here you will see, I'm just gonna deselect this one, I don't want that one. And here you will see a HTTP code which is 301, which is permanently moved, which means any request which is landing on HTTP will be redirected to HTTPS, so that it's only serving from a HTTPS. So click on the save changes over here. And as you can see, successfully modified the listener, and now you need to wait a couple of minutes or a minute, and then it will start redirecting the normal HTTP request to the HTTPS. Let's open a new tab over here, and here I'm just gonna paste the URL, and here you can see this URL is ending with HTTP. I'm not using HTTPS, and once I hit enter, then it should redirect me to the HTTPS. So click on here, and here you can see it has redirected me to HTTPS, which you can verify from here. Connection is secure. So this is how you are just gonna set up your SSL, and then you can also redirect your normal HTTP request to HTTPS. And in case if you are using some other domain, let's say for example www.jhook.org, then there is again a different name. So you need to request a certificate for that particular domain name as well. So you need to create a new certificate, and there you need to enter the root name as www.jhook.org and request a new certificate for that particular domain as well. And then push those record into again to our Route 53, and then after that you will be able to to access the URL or the home page using the www URL pattern as well. So this was a small session on how to handle your SSL with our AWS Certificate Manager, and I hope you like this session. Then please put down into the comment section whatever queries you have, and please consider subscribing to this channel. And also, if you are new to this channel, then I have already uploaded 15 sessions on AWS. So if you are just getting started with AWS, then I would highly recommend to go through those sessions as well. Those are also quite in-depth sessions. Also considering subscribing to the membership program of this particular YouTube channel, where I also keep on sharing more in-depth level session only for the members of this particular YouTube channel. So if you are interested, then please check out the membership program as well. So see you into the next session of our DevOps and AWS. Till then, take care and bye bye.